This is problem 6 of section 1.5. This is asking us to find vertical asymptotes. If you remember your college algebra days, they defined a vertical asymptote as anywhere where the denominator of the function was undefined. In fact, that's how you found them. From a calculus standpoint, we can see that that's not entirely truthful. And we have to dig a little bit deeper to determine that, okay, we found where the denominator is undefined, but is that actually a vertical asymptote, or is that just a hole in our graph? So when I look at this one, the values I want to consider though are what values make that denominator equal to 0. And so I have x squared equals 0 if and only if x equals 0. And so that's going to be the value that we're going to look at. What happens when x is equal to 0? Is that a vertical asymptote, or is that just a hole in our graph? And so let's go ahead and look at what happens as x approaches 0 from the right of 9 over x squared. Okay, so again, this is where I kind of wave my hands and do some campfire talk. If you want to look at a graph, you could do that as well. If you want to kind of write down some of the scratch work, campy talk, you can do that and then, scratch it off. But I really encourage you for your assignments, feel free to put in some of that scratch work because that kind of helps me to see your thought process. But if you're writing up a professional math paper, you probably wouldn't include those, little notes of what this is approaching, what that is approaching, that I'll do here. So if I'm looking to the right of 0, I'm going to look at very small values, but they're still going to be positive. Okay, so I have this 9 in the numerator. That's a constant. We could even factor that out. We don't really have to worry about that. But, if I look at small values like x equaling 1/10, okay, well, then this is going to have a value of 90. If I look at x being 1/100th, then this is going to be a 900. And so I'm kind of just making a table essentially. And then hopefully what you see is that as that denominator gets infinitesimally small, if I divide 1 by something that's getting infinitesimally small, this as a whole then is going to go infinitesimally large. And then that 9, all that does is it just helps us get, larger faster. So we have this. So this is definitely, if we approach 0 from the right, we see that this is going to approach infinity. So that's a good start. Let's go ahead and look at what happens as x approaches 0 from the left. This is going to run very similar. And in fact, I may have even misspoke a little bit on the last example. Because when I look at this 9 over x squared, we have this, we could have like a 1/10 x squared equaling 1/10. Even though we're picking very low negative, we're still squaring it. And so this is going to be 9 over that 1 over 100. So this is going to be that 900. And we're going to see that similar pattern. That denominator is going to get infinitesimally small, close to 0. And when we divide by that, it's going to cause the 9 over x squared to grow. Because a negative squared is always positive, we are going to just approach positive infinity. And so we end up having a limit as x approaches 0, whether from the right or to the left, of 9 over x squared. That is just going to approach a positive infinity. And so as a result, since that, if you think about what the graph is going to look like, whether I'm going to 0 from the left or from the right, it's growing without bounds. That tells me that I'm going to have that vertical asymptote. I'm never going to get to a point where x can equal 0, but it's more than just a hole. It's not defined even at the right or the left. It's growing without bounds. So then we have a vertical asymptote at x equals 0. And so that's a line. So we do want to put that x equals 0. We don't want to just put 0 because 0 is just a value. And in this case, we want to define a line. And in this case, it's a vertical line. An asymptote is a line. So make sure you put the equation x equals 0 in your answer.